Uh, Hello, dear. In this today's lecture, we are going to talk about Newton's second law of motion, and we will solve the problem related with the free fall and how we can find the normal reaction. So, when we are applying a force to a particular object. So, what is Newton's second law of motion? So, Newton's second law states that rate of change of momentum to a particular body, so that is equal to the force applied to that body. So generally everybody knows that we use the formula F is equal to ma, but actually how we can find the acceleration of that body when we are applying some force to that. So what is rate of change of momentum? So that is delta P over delta T, which is equal to force applied. So how we can solve or find this equation of Newton's second law of motion? So if we write here as F, which is delta P over delta T. So what does it mean? Suppose a body which is having a mass m and we are applying a force F to that body, and suppose initially this body is moving with the initial velocity u, and after when we apply the force it starts to accelerate and starts to move with the velocity v. So here its initial momentum is m into u, final momentum is m into v. So rate of change of momentum is final momentum minus initial momentum over time taken. So we can write it as mv minus mu over t is the time taken. M we can keep it common, take it outside. So what is this u minus v? So that is rate of change of velocity. So how much velocity of that body has been changed? So that is the definition of acceleration. So we generally define acceleration as rate of change of velocity. Rate of change of velocity means delta v over delta t, so which is generally written as v minus u over t. So this is how we can derive the formula F is equal to ma, which is Newton's second law of motion. So with the help of these formulas we can find the acceleration of a particular body, we can find the retardation, so when we are applying brakes, so the related numerical problems. So the next important topic which we will discuss is the free fall body of a object, or the behavior or the force acting on a body when it is moving in a lift. So in this example you can see that a person who is standing in an elevator, and elevator it is also indicating the total uh, force which is being applied. So in this, the total force which is known as the apparent force, which is the normal reaction, so which is being given by this body. So to draw this free body diagram of a body, suppose the weight, it is being always in the downward direction, and opposite to it is known as the normal reaction. In some books it is written as n, in some books it is written as Fn. And the acceleration, since it is moving towards the downward side, so it will be downward. So acceleration due to gravity, which is also by the earth, which is in the downward direction. So here the total force, which is mass into acceleration, which is equal to the normal reaction, which is in the upward, minus the weight of the body, which is m into g. So from here we can find the value of Fn. This comes out to be equal to mg plus ma. So there are 4 cases. So in the first cases, when a person it is standing in an elevator and the lift is having no acceleration, the elevator is in the still motion. So in that case, so where the lift is having no acceleration, this component will be equal to 0. So here the normal reaction in first case will be equal to the weight of the body, which is m into g. So that's why the indicator or the weighing machine is showing the same force as that of the weight of that person. The second case is when the elevator is moving in upward direction. So we know that when it is moving in upward direction, we always generally consider it as plus a. So when the body is moving in minus direction, we generally consider it as minus a. So when it is moving in upward direction, the total force the weighing machine shows that is equal to mg plus acceleration is positive, so which is ma. So that's why this weighing machine is showing a large force, which is sum of its weight plus m into a, that is the acceleration applied on that body. Third case is when the body is moving in downward direction. When the elevator is moving in downward direction, so in that case, in the downward direction, so Fn will be equal to mg minus ma. So Fn mg is 700 and Fn has a value less than the weight of that body. That's why the weight of the person is 700 Newton and the elevator is, the weighing machine in the elevator is showing the less reading. So which shows that the lift is moving in the downward direction. Fourth case is the free fall case. In free fall case, the lift is moving with a acceleration which is equal to acceleration due to gravity. So in that case, the value of a is equal to g. So therefore the total normal reaction force will be equal to mg into ma. So a in a free fall is equal to g. So the total normal reaction will be equal to 0. That's why in a free fall case, this scale is showing 0 rating. So this is how you can find and solve the problem of the lifts using this formula. Fn, that is the apparent weight. Apparent weight is that weight which is showing, and it is dependent upon whether the lift is moving upward, it is moving downward, it is still position, it is in free fall. So this apparent weight is changeable, so this value can be changed, while the true weight is always have a same value. So the apparent weight is having different values depending upon the different scenarios, and it is dependent upon the acceleration of the lift, whether it is moving upward, moving downward, in a free fall, or in still position. So let us try to find a numerical problem related to same case. A stack of books whose true weight is 165 Newton is placed on a scale in an elevator. So some books have been placed whose weight is 165 Newton. The scale reads 165 Newton, and the scale which is in the elevator, it is also showing a reading of 165 Newton. So from this information, what we can analysis? Can you tell whether the elevator is moving with a constant velocity of 2 meter per second upward? Second, the elevator is moving with a constant velocity of 2 meter per second downward, or elevator is at rest. So here, since the apparent weight and the true weight, they are showing the same scale. So this is our apparent weight, and this is true weight. So how we can solve this? If we can find the value of this acceleration, but the apparent weight is equal to true weight, so it means that the acceleration in this scenario is 0. Now acceleration when can be 0? So acceleration can be 0 when the body is at rest. So number one case, when acceleration can be 0, when body is at rest, or when elevator is at rest. So this is possible. Second, when acceleration is 0, when the velocity is 0, since the elevator, when it is moving with constant velocity either up or down, so if it is moving with constant velocity, so there is no change in velocity, or if there is no change in velocity, what does it mean? It means it is having a 0 acceleration. So a body which is moving with a constant velocity, it is having a 0 acceleration. So from this given scenario, we cannot tell the exact correct answer. So in all the three cases, the acceleration is 0. So the case 1 is also possible, the case 2 is also possible, and the case 3 is also possible. So therefore all three scenarios result in same scale reading. So it all depends upon the value of acceleration. So since in all the three cases acceleration is 0, So all the three cases are possible for this case. So next question, a 10 kg suitcase is placed on a scale that is in an elevator. In which direction is the elevator accelerating when the scale reads 75 Newton and when it reads 120 Newton? So 10 kg suitcase, so its weight, acceleration due to gravity is 10 meter per second square. So weight will be towards downside, which is equal to mg, which is 10 into 10, 100 Newton. But the scale is showing 75 Newton. So when the scale is showing less reading, when the elevator is moving downward. So when it is showing 75 Newton, it means the elevator is moving downward, and when it is showing more reading than 100, which is 120, it means the elevator is moving upward direction. So we can generalize from here, elevator is moving downward when it reads 75 Newton, and elevator is moving upward when it reads 120 Newton. So 75 Newton is less than 100 Newton, in which case when elevator is moving downward. Second, 120 Newton is greater than 100 Newton when elevator is moving upward. So option A in this is the correct option. So sometimes the numerical also comes, so when two masses which are in contact with each other, and when we apply a force, so they ask you to find the normal reaction between the blocks and what is the acceleration which is acting on both the blocks. So such type of problems, how we can solve? So suppose we have mass m1, a bigger mass of m2, we are applying a force of m. So for this we need to first draw the free body diagram for mass m1. So suppose this is mass m1, its weight will be downward, its normal reaction will be upward, the force we are applying in this direction, and it is accelerating. So if it is accelerating, it is means it is having a positive velocity. So from here the normal reaction will be equal to m1g. But what they have asked the normal reaction between the two blocks. So apart from that, what this m1 it is applying, because both are in contact, so it is applying a normal reaction of n1 towards m2, and the same normal reaction n1 n dash, the m2 it is applying to m1. So from here we can write F, which is in the positive side, this n1 or n dash, m2 is applying on m1, it is in this side, it is minus from the total force, and the m1 is accelerating. So we can write m1a. So this is the free body diagram for mass m1. Now for this mass m2 we will draw the free body diagram. This is our m2. Its weight is m2g. Normal reaction is again upward. Now here this body is moving because of this m1 push. So this force is applied on m1 and m1 is generating a normal reaction n dash. That's why this m2 is also moving forward. So from here n1 and n dash is again positive side. It is accelerating. It means it is having positive v. So the second equation is n dash, which is equal to m2 into a. So adding these two equations, so when we add this get cancelled. So total force acting on these two blocks is m1a plus m2a, so which we can find, that is m1 plus m2 into a. So from here we can find the acceleration, which is equal to m1 plus m2. So once we find the value of acceleration, from that we can find the normal reaction between the blocks. The normal reaction between the blocks is n dash, which is m2, putting the value of a in this equation. So the normal reaction is m2 into a. This we can write down as m2 f over m1 plus m2. So this is how you can find the total acceleration applied when we have a stack of different masses of boxes which are in contact with each other. So let us try to solve similar problem. Two blocks of mass 3 kg and 2 kg are in contact on a frictionless horizontal surface. So there are two masses, one is 3 kg, second is 2 kg. They are in contact. We are applying a force of 10 Newton, and this is moving accelerated in the positive side. So what we have to calculate, what is the magnitude of the contact force between these two blocks. So we have to find the magnitude of contact force. So that is the normal reaction which is acting between these two forces. So how we can calculate? So we can calculate the acceleration F over m1 plus m2. So F is 10 Newton, m1 is 3 plus 2. So acceleration is coming out to be 2 meter per second square. So the force acting between these two blocks, that is the n dash force, and we have derived the formula n dash, which is equal to the second box multiplied by acceleration, or you can use this formula, which is m2 here is 2 kg multiplied by force is 10 Newton over m1 plus m2. m1 is 3 plus 2, that is 10 into 2, which is 20 over 5. So it is coming out to be 4 Newton. So the force acting between these two blocks is 4 Newton. So this is how you can solve such problems. So next question is, a lift is falling freely under gravity. A person inside the lift drops a ball. What will be the acceleration of the ball relative to the person? So a person is standing in the lift, it drops a ball, so person is also moving with acceleration a, and the weight of is mg. So similarly, both are in free fall case. We have observed the total acceleration or the total weight that becomes in the weightless case. So the acceleration of the ball relative to the person, because both the person it is also in a free fall, the ball it is also in a free fall, so both will fall with the same acceleration. So if they are falling with the same acceleration, so their relative motion will be 0. So answer will be equal to 0. So this is another set of forces, how we can find the magnitude of the contact forces. Here find acceleration of all blocks and the contact force between 4 kg and 3 kg block. So the formula of acceleration is force over sum of all the masses, that is 2 plus 3 plus 4. 4 applied is 8 Newton. 4 plus 3 7 plus 2 9. So acceleration is 8, it is 18 Newton. So 9 into 2, so acceleration coming out to be 2 meter per second square, and we have to find the normal reaction or the contact force a 3 kg which is applying on 4 kg, and the same 4 kg it is applying on the 3 kg. So that is n dash, which is on the 4 kg mass, 4 into acceleration, that is 2. So it is equal to 8 Newton. So the normal reaction between the 4 kg and the 3 kg block is 8 Newton. So this is the numericals related with the elevator problem, or how we can find the acceleration and the normal reaction when 1, 2 or 3 bodies which are moving with some finite acceleration. I hope you will understand this concept. If you have any problem, you can ask.